Hello everybody, my name is Ethan. Welcome back to the channel where today we are going to be hopping back in to the machine learning course on Codecademy. In the previous videos, we started the command line chapter. We did the intro to the command line and then some more intro basics. So those were split up into two videos, part 1 and part 2 of command line basics. So if you missed that, please be sure to go check it out. In today's video, we're going to be learning about redirection. So hopefully you guys will enjoy this video. I do want to address something that actually happened in the last two videos. I recorded them back to back just to kind of split them up, make them a bit easier. But my friend DMX Monkey was not in them, and that's because he went on vacation. So here he is. He's back. He's back from vacation, and he is ready to code. So had to kind of move on without him. I hope you're not too mad. I don't think he's too upset. So I think we're good and we can keep going. So hopefully that's okay. All right, let's get into redirection. Hopefully this should be a good little chapter and a good video here. So in the introduction, it says up until now we've run commands in the command line and received a stream of output in the terminal. In this lesson, we'll focus on input and output I/O redirection. Through redirection, you can direct the input and output of a command and to and from other files and programs, and chain commands together in a pipeline. Let's try it out. You can reference the file system for the lesson here. What happens when you type this command? So if we type echo, and then in quotation marks we type hello, it's going to just print out hello. So that's something that we've seen before. When we are in Python, we can actually see that when we type print hello, it'll actually print that hello statement, the thing that you can see in the second line here, to the console like it does here. But in this case, we can also use the console by saying echo hello to also put hello. The echo command accepts the string hello as a standard input and echoes the string hello back to the terminal as a standard output. Let's learn about more standard input, standard output, and standard error. Standard input, abbreviated as STDIN, is information input into the terminal through the keyboard or input device. Standard output, abbreviated STDOut, is the information outputted after a process is run. Standard error, abbreviated STDERR, is the error message outputted by a failed process. Redirection reroutes standard input, standard output, and standard error to or from a different location. All right, my first redirect. How does redirection work? I guess this is the greater than symbol, but the greater than command redirects the standard output to a file. Here, hello is entered as the standard input and then redirected to the text file hello.txt by the arrow, we can call it too. As a reminder, cat command outputs the content of a file, so when you type cat hello.txt, the contents of hello.txt are displayed. The exercise in this lesson uses the check work button. Again, you guys aren't able to see the check work button, but just know it's right behind my webcam here. I don't want to mess it up and move my webcam because we kind of have a theme going on of my webcam being in the lower right-hand corner, so might as well not change that just for you guys to see a check work button. The exercise in this lesson, again, use check work to move through the instructions, perform the task, click check work. If you accomplish task correctly, you can move on to the next task or exercise. So it wants me to type echo hello world, and it wants me to redirect it to hello.txt. So once we do that, again, we can check our work. Then if we type cat hello.txt, we'll see that it prints out the hello world. Perfect. So redirection. Cat desserts.txt to hello.txt. The greater than takes the standard output of the command on the left and redirects it to the file on the right. Here's the standard output of cat desserts.txt. Here, the standard output of cats.desserts.txt is redirected to hello.txt. Note that greater than overwrites all original content in hello.txt. When you view the output data using cat on hello, you'll see the contents of desserts. Let's practice some redirections some more. The working directory is geography. We can check our working directory to just check that, yes, we are in fact in working directory. I should be clearing these also right before everyone so we don't have it, so you can kind of get an idea of what's going on at this page. So we print our working directory. We can see we're in the workspace geography. That's where we're at. We can reference it to start. We can print out the output of the contents of this directory by putting in ls, and we can see we've got a lot of different text files here. So we can check our work here. We want to use the cat function to view the file continents.txt, and we get a list of the 7 continents here, all in, it appears, alphabetical order. Next, we're going to redirect the contents of ocean to continents. So we can do that by doing the echo, and we'll take the contents of oceans.txt, and we are going to pipe that into continents.txt. And make sure I'm spelling everything right. Yep. Now that we've rerouted, I thought that's exactly what I did. Maybe it wants me to, I see cat. Because I actually want to see what's inside the file. So now if we do cat on continents again, we'll see that the previous time we used it, we got all listed the 7 continents. This time we get the 5 major oceans, right? Also in alphabetical order. All right, double arrow symbol means now we know how to overwrite a file's contents, but what if we want to be able to add to a file without losing the original? We double it up and use 2. 2 greater than symbols takes the standard output of a command on the left and appends it, adds it to the file on the right. Here, the output data of hello.txt will contain the original contents of hello.txt with the content of forest.txt appended to it. So again, I am going to just clear. I'm going to do the same thing where I do a little bit of where we are, what's inside of it here, and then we'll see. It wants us to add the contents of glaciers.txt. So we have got glaciers.txt, and we want to append it to rivers.txt. And doing that, we will be able to see now if we print out the contents of rivers.txt, we can see we have all the rivers, right? A lot of the major rivers. Again, in I thought it was, it's not alphabetical order, but we also see a lot of the major glaciers added on. So perfect. Now we have the less than symbol. Less than takes the standard input from the file on the right and inputs it into the command on the left. Here, deserts.txt is the standard input for the cat command. The standard output appears in the terminal. Again, I am going to just quickly clear all of that. While this example above accomplishes the same thing as cat deserts.txt without the redirect, it is important to know that an input can be redirected. Oh my, excuse me guys. I don't think that's ever happened in a video. Cat lakes.txt. And again, this is exactly the same as writing cat lakes.txt, as we can see. It's exactly the same. All right. Toolbar is a pipe. The pipe takes the standard output of the command on the left and pipes it as standard input to the command on the right. You can think of this as command-to-command redirection to count the words in volcanoes.txt using the word count command. We can do cat volcanoes.txt. I am going to clear again. Let us know where we are and what our contents are. Above the output of cat volcanoes text becomes the standard input of word count. In turn, the word count command outputs the number of lines, words, and characters in volcanoes.txt respectively. Multiple bars can be chained together. Above the standard output of cat volcanoes.txt is piped to the WC command. The standard output of WC is then piped to cat. Finally, the standard output of cat is redirected to count.text. We can view the output of this data by typing cat count.text. Let's try this. So in the terminal, we're going to write cat volcanoes.text, and we're going to pipe that into WC. So when we do, we get these three numbers, and I assume this stands for the amount of lines, the amount of words, and the amount of letters. Now, if we type cat volcanoes.txt piped into word count, piped into cat, which is then put into volcanoes. Okay, we typed that. Now we can use cat on volcanoes count, and we get the same exact thing, right? So in this example, we just printed out to the command line here what the values were. In this case here, we actually saved that this string of text here to volcanoes.count_count.text. Sort. Sort takes the standard input and orders it alphabetically for the standard output. It doesn't change the file itself. Here the consonants in consonants.txt will be listed in alphabetical order. Here the sort command takes the standard output from cat glaciers and pipes it into sort. The standard output of sort is redirected to a new file named sorted glaciers. Makes sense. I am going to clear pwd ls to tell us what we are, where we are, and what we have to work with. We're going to first use cat to view the contents of lakes.txt. So there we are. We've got all these lakes here. Then we're going to sort it. So we are going to take the value of, I guess we want to just sort lakes.txt. So again, now we've sorted them. So we can see that Lake Victoria V at the end of the alphabet is at the bottom. So now it wants us to use the greater than symbol to save the sorted lakes.txt file as sorted-lakes. So if we kind of look here, what we might want to do first is we'll take our first input of cat lakes.txt, pipe that into a sort command that then will pipe into a new file called sorted-lakes.txt. And if we check our work, looks like we did it correct. Now use cat to output the text of sorted text, and we can see it should look exactly the same as this one, and it does. So that's very nice. I'm going to clear again and then do the same thing I've been doing. For some reason it puts it on 2 lines now. I guess it's because we have multiple we have multiple things now. All right, UNIQ stands for unique. It filters out adjacent duplicate lines in a file. So above unique deserts text filters out duplicates Sahara Desert. So you can see here we have 2 duplicates there of the Sahara Desert. Because it duplicate directly follows the previous instance, the Kalahari Desert duplicates are not adjacent and thus remain. So it looks like since they are right here back to back, right, Sahara, it gets rid of them. But since the Kalahari and the Kalahari are not adjacent, it actually adjacent duplicate lines. Yeah, so it doesn't filter them out. A more effective way to use unique is to sort a file, and then, I see, so you want to sort it first and then use the unique function, right? Makes sense. It would get all of the adjacent files next to each other, and they would be, then you'd be able to use unique on it. So first it wants us to cat the output of deserts .txt. And we can see in here we have, again, these two Sahara deserts, and then we have a Kalahari desert and a Kalahari desert. So then we've noted the duplicate entries, unique. We're going to use unique to remove the duplicates. So we can do that by using unique deserts.txt. And as you can see, it's gotten rid of the two Sahara deserts and just put one instead. But if you notice, we still have two Kalahari deserts here. So that's probably what we're going to be doing here. So we're going to use the command above before piping into unique. You'll see the output contains no duplicates now. So if we do sort deserts.text and pipe that into a unique function, it outputs all of them in alphabetical order and sorted so that there's only one of each. As you can see now, there's only one Kalahari. grep1, grep stands for Global Regular Expression Print. It searches files for lines that match a pattern and then returns the results. It is also case sensitive. Above, grep search for anything that matched America in continents. So again, it's going to search for lines that match a pattern and then return the results. So in this, we used grep America on continents, and grep -i enables the command to be case insensitive. Here, grep search for capital or lowercase strings that match America in continents. Note that we don't use quotes in our command. The above commands are a great way to get started with grep. If you're familiar with regular expressions, you can also use regular expressions to search for patterns in files. So I'm going to do the same thing that I've been doing. And we're back. Oh, darn it. First, it wants us to output the command, output the contents of mountains.txt. So we'll do that. You can see we've got a bunch of mountains here, and we can click check work. We're going to use the grep command to search for anything that matches mount. So we can do mount in mountains.txt. The case should be case sensitive, so we'll do this. And we find that the Hindu Kush Mountains, Henduin Mountains, Atlas Mountains, Mount Kilimanjaro, and Trans-Antarctic Mountains. So it is case sensitive. We're going to do the same thing, but we're going to be case insensitive. So we'll do the -i, and then again do mount, and then mountains.txt. And this time we get a lot more because there are some that weren't capitalized, like the Appalachian Mountains, right? All right, grep2. Grep -r, used right here, searches all files in a directory and outputs file names and lines containing match results. -r stands for recursive. Above, grep -r searched the geography directory for the string Arctic and outputted file names and lines with matching results. So it outputted Arctic desert and then Arctic ocean. So it searches all files within the geography, all directories inside, and then also all files inside. I'm going to just quickly clear pwdls. And then finally, we have another one. grep-rl searches all files in a directory and outputs only file names with matched results, so no lines. L, which is lowercase l, not capital I, and not the number one, stands for files with matches. Here, grep -rl searched the geography directory for the string Arctic and outputs file names with the matched results. Right? So it doesn't explicitly state what it found. It just says, yep, these files have something in them. All right, so using grep search through the working directory, we'll do that. We want to do -r then, -r for the word island. So we'll do island, and then we'll do the command home, cc user, workspace, and then geography. And when we click that, we can find that we find a bunch of different ones with the word islands in them and the islands tag, right? So we're going to do the same thing here, but instead no matching lines. So minus RL, and then we can do island again, and then we'll do the same /home /cc user /workspace /geography. And we can see only one of them actually finds it, and that's because it's just the main islands text, right? So end up working fine. We just get the idea that all of these are inside just the islands text, right? SED. SED stands for Stream Editor. It accepts standard input and modifies it based on an expression, but for displaying it as output data. It is similar to find and replace. Let's look at the expression s/snow/rain. S stands for substitution. It always used when SED for substitution. Snow, the search string, and then rain, the replacement string. In this case, said search for forest searches the forest.txt for the word snow and replaces it with rain. Importantly, the above command will only replace the first instance of snow on a line. So in this above command, it's saying that because we didn't include this G here, it's only going to do it on the first part of a line, the first line, the first instance of snow on each line, right? Adding the G means global. Here, said searches forest.txt for the word snow and replaces it with rain globally. This means all instances of snow will be turned into rain. SED, as we've used it, only rewrite the command line output, and the actual file won't be changed. In order to rewrite the actual file, we need to put -I in the beginning of the command, and that will make it change the actual file. The above command will rewrite forest.txt and replace all instances, since we're also using G of snow and with rain. All right, let's use cat to display forests.txt. We can see all the different forests that are in our data set here. Use SED on forest.txt to replace just the first appearance of snow. So we're going to use sed, and then we'll use at substitution. I want to get rid of snow, and we'll instead put rain. You can get that out, and then we'll do it on, we'll have to specify we're doing it on forest.txt. And I believe that's everything in there. So we'll click that. We get unterminated S command. Did I do it wrong? I did. I didn't put an extra thing there, so that was my mistake. /snow/rain/ missed the second slash there, and then we'll redo forests.txt, and now it's done all of them with on the first line, I guess. We're going to do it again to replace snow globally, right? So we'll do s/snow/rain/G. And then we'll do that same forests.txt. You can see now in here, previously it said Pacific temperate rainforest snow forest. Now it says Pacific temperate rainforest rainforest. So super useful. If you can use cat to view the contents of forest, you can see that no changes have been made. Use sed and permanently replace. So we'll have to do the same sed command, but include the -I, and then we'll do the same s/snow/rain/G in forests.txt, and now it's completely rewrote all of them, and we can use cat one more time on forests.txt and see that they've all been permanently changed. Review. Congratulations, you learned how to use the command line to redirect standard input and standard output, but what can we generalize so far? Redirection routes standard input. We can see all the different ones here and the commands that we learned, which is sort, unique, grep, and sed. So, perfect. I think we'll probably end up having a quiz. Yep, the unique command removes duplicate. Duplicates only if they're adjacent. Correct. What does the less than symbol do? Redirects input into a command, right? The echo command takes a string as std in and prints the string at std out, right? Append the string Aesop rock to the file greatest.txt. So we want to do appending the string. Echo is the string, right? And then we can append it to greatest.txt, right? How would you pipe the results of one command to another? Using the piping command, which is this. Search the file greatest.txt for URL, and then send the results of the file to odd.future. So we want to search the file greatest.txt. It's not this one, obviously, and on this one. We want to have this grep URL greatest.txt, and then send the results to the file, piped into the file. Yep. Since this one wouldn't work because you're trying to pipe two commands here, this is just a text file, so it's not a command, right? So you'd actually send it there. It doesn't say append, and that's why I was a little bit confused on that one. What command outputs the string lamar to the file greatest.txt? Not cat, not move. We can put echo lamar into greatest using that way. What command searches all files recursively for Gambino? Period is I don't understand the period there. I knew that -r searches recursively through everything. What what commands would sort the contents of the file and then print them? I think any of these would, right? Was the correct answer? It takes the output and then so we have. I guess it is piped just into a command. Yeah. What does the S stand for in substitute? Well, we got one wrong, and it's because I was a little hasty with it there, but that one was a good test there. All right, we got an objective called Athletica. Print in the working directory. So we can print our working directory by doing pws, list all files in long format. If you missed that, including hidden files. We can see there using AL. We can use cat to view the contents of basketball.txt. It looks like a string here. We can use cat to view the contents of hockey.txt. Another string. Redirect the standard output of basketball into. So I'm going to do hockey.txt. Are we just piping it in? Yep, we are. And that would be basketball.txt into hockey.txt. Then view the contents by doing hockey.txt. View the contents of lacrosse.txt. Lacrosse. Append the contents of lacrosse. So same thing. I'm going to do cat lacrosse.txt, pipe it into tennis.txt, and then if we do tennis.txt, see the lacrosse description. Redirect the contents of gymnastics as a standard input for the cat command. We can do that by doing the less than command on putting gymnastics.txt. See the description. Pipe the standard output of cat lacrosse.txt to the word count command. So we can do that by doing word count. View the contents of equipment using cat equipment.txt. A lot of interesting equipment. Sort equip. Now it is sorted. Use the unique filter. Don't see any duplicates in here, so I think we're good. Using the grep command to search roster for players from Japan. Grep Japan roster.txt. Use the grep command to search for the string player in the current directory. Dot, and output file names and lines for matched results. So we would do grep -I for matched results. Oh. So boom. I did that right. Looks like I did it right. All right. That is going to be it for today's video. If you did enjoy, please be sure to leave a like. We went through all of Redirection. In the next video, we're going to be covering configuring the command line environment. If you did enjoy, please be sure to give a like, subscribe, and I will see you in the next one. Peace out.